Hi, my name is Tim Quinn. I'm a member of Oracle's engineering team working on Project Helidon, a set of libraries which helps Java developers write microservices. Today, I'll be talking about and demonstrating Helidon support for metrics exemplars. Basically, in microservices, metrics allow us to capture and report important aggregate values which reflect the overall performance of the application. This can include measures such as the number of requests the server receives, the distribution of execution times over all requests, and so forth. Typically, each request contributes a sample, an observation, to various metrics. A sample can have a timestamp and might indicate simply that an event has occurred, such as the arrival of a request, or convey a value, the processing time for a request. We provide Helidon in two flavors. Helidon MP implements the Eclipse microprofile specification and includes full support for annotations, interceptors, and so forth. This includes a complete implementation of the microprofile metrics specification. Helidon SE includes a reactive web server and gives the developer complete and explicit control over how the server behaves. Helidon SE does not process annotations, so there's no magic behind the scenes, and Helidon SE implements metric types inspired by the microprofile metrics. Both SE and MP automatically add the endpoint /metrics to your application, from which clients can retrieve metrics output. Like metrics, tracing in microservices helps us get insight into the performance of a server. But tracing gathers information about single requests rather than aggregating data about multiple requests as metrics do. Typically, tracing counts and times the work done in processing each request. A span is a distinct part or step in the work which the server performs as it responds to a request. A trace is a collection of all the spans which describe a single request. Helidon offers support for both Jaeger and Zipkin tracing. Exemplars bring metrics and tracing together. The idea is to associate with most metrics a specific sample, a request, that is in some way representative of the metric's value and link the trace ID of that sample with the metric. In fact, a dictionary definition of exemplar shown in the box on the slide is very much in line with this, one that serves as a model or example, such as an ideal model or a typical or standard specimen. As an example, suppose we had a metric measuring the mean of some value, say request execution time in milliseconds. We sent requests A, B, and C to the server, and request A took 4 milliseconds, B took 3, and C took 8. The mean is 5, and in this case, none of the samples actually reported that exact value. The sample which reported the closest value is A, which reported 4. So for this metric, the exemplar is sample A. One of the metrics formats Helidon supports is Open Metrics, or Prometheus, and there is a conventional way to add exemplars to that format as a trailing comment. The Open Metrics exemplar format includes 0 or more labels, typically a trace ID, enclosed in curly braces, followed by the metric value that was contributed by that sample, followed by the time when that sample's value was recorded. Beginning with Helidon 2.3.0, Helidon SE and MP both support exemplars with Open Metrics Prometheus output. In the demo we'll do today, we will illustrate how you can easily add exemplar support to an existing Helidon MP application. We'll begin by starting the Zipkin server locally. We will create a new Helidon MP project, the Quick Start app, which accepts requests and returns either generic or personalized greetings. Then we'll modify the app. We'll add some dependencies to the POM, and we will add metrics annotations to a couple of the endpoints in the generated application. Then we'll access the app to retrieve some greetings. We will retrieve the metrics from our server, and then we'll browse Zipkin's collection of the traces which our application sent to the Zipkin server, and we will be able to match up the traces in the Zipkin user interface with the metrics that were reported from our server. Let's take a look at the demo. We'll begin by launching Zipkin. which we'll do in a Docker container. Now that Zipkin is up and running, and we'll be using it later, we can use the Helidon CLI to initialize a new project. We'll choose it to be an MP project. Based on the quick start example, we can take the defaults for the remaining options. And at this point, that code has been generated for us in a new example project. We can go ahead and open that project in an IDE and begin working with it. The first thing we'll want to do is change the POM file. The generated POM has a dependency on Helidon's microprofile bundle, but we need to add, for the purposes of the demo, the tracing Zipkin integration, as well as a second dependency for the exemplar support. Now that we've added those dependencies, we'll just click up here to notify the IDE that we have modified the POM. Now we can come back. Let's change into the generated directory where the project resides. We can use Helidon's dev loop to constantly monitor the project files, and whenever there's any change, it will automatically rebuild the project and restart the server. So what we'll do is navigate to the JAX-RS resource class, greet resource. This contains the endpoints and their implementations in the greeting example that we generated from the CLI. So one thing I want to do, I'm going to create a constant, which I'll be using in defining two annotations. The endpoints include two get methods. One of them returns a default message, hello world. The other one returns a personalized message using the name parameter that's passed in with the request. What we'll do is we will add a new timed annotation. And what we'll do is we'll set the name. We're going to call this absolute equals true, which will make the output a little easier to see and understand, and we're going to make this a reusable timer. I'm also going to copy that annotation and apply it to the other get method. So now we have one timer that will accumulate the timing results for either of these two get methods. And with that, we can save the file. The CLI dev loop has discovered the change. You saw in the background that it rebuilt the project and restarted the server. All right, now let's go ahead and ping our server. It's listening at HTTP localhost 8080. We can ask for a greeting, and it comes back hello world. We can ask for a personalized greeting, and it comes back with the name of the person that we specify. We can post a few more just to build up our statistics. Now let's take a look at the metrics. And because we added the annotations to our endpoints, we can ask for only the application metrics. And let's take a look at what we see. Here's the output for the all gets metric that we added, the timer. It's telling us the rate per second. It's giving us rate per second within the last 1 minute and 5 minutes. But more importantly, let's take a look at the mean seconds. This is the average length of time that requests to either of those get methods spent doing the work. And what we see is here is the appended comment at the end of the open metrics output for that mean value. And here's the trace ID corresponding to the exemplar, the sample that most closely represents the current value of the mean metric. This number here is the actual value contributed to the metric by that sample, by that request processing. And you'll see that it's not the same value as what the mean has been recorded as, and that only makes sense, as in the example we saw in the slides. Notice that for the max, we have a different trace ID, and for the min, for that same all gets metric, we have yet a third trace ID. One of the features of the timer metric is it maintains some information about the distribution of the times that the metric recorded, and we can see that within those values reported in the output, there are several different traces represented. Now what we can do is use the browser to contact the Zipkin server that we have running locally, and when we run the query, we can see the various traces that the Zipkin server collected as our application transmitted those traces to it. If we expand all, we can see the trace IDs that Zipkin has recorded and is displaying, and we can match them up with the trace IDs that we see in some of our metrics. For example, we've got a trace ID ending in 7C4 here, and that happens to be the one that was the maximum exemplar. So let's go ahead and take a look at the trace for that. If we enlarge this part of the display, we can see that there was apparently a fair amount of warm-up time required to get the code path in the server up and running. And then there's some security-related steps or spans, and then the writing of the content to be returned in the response took a little bit of time there. Let's go back and look at another trace. Let's see which trace was corresponding with the mean, and it was this one ending in 37CF. So let's look for that one. Here's 37CF, so we'll take a look at this trace. And here we see a breakdown of this trace for this request into its spans, showing somewhat different times from those in other requests. Because Helidon's exemplar support associated this trace's identifier with the mean metric, this request's processing time was the closest of all requests to the reported mean value. So that's really all we have to do to add exemplars for linking metrics and tracing to an existing Helidon MP application. To find out more information, you can go to the helidon.io/docs website, and the easiest way is to navigate to Helidon SE, and then to metrics, and then to metric support for exemplars, or similarly on the same page to Helidon MP, then metric support for exemplars. There's a long URL here that talks about exemplars in the Prometheus and OpenMetrics environment. And I'll also add links in the description for this video so you can click directly on them there rather than have to copy from them here. I hope you found this informative and interesting, and thanks for taking some time to watch.